All right, so Precalculus Notes 5.1, Day 2. The warm-up is just to show you some algebra. You're going to be doing these with trig functions. And so imagine x is cosine x, y is sine y. And so you're going to be doing these operations with trig functions. And this is just to kind of go back and review the algebra without the trig functions in there. And so if you need to add the first two, you need a common denominator. And the least common denominator is xy. And so you need to multiply the first fraction by y over y. And you need to multiply the second fraction by x over x. That's multiplying by 1 won't change the value of a single expression. And so then our common denominator is going to be xy, and you get 2y plus 3x. And so that's it. That is your answer for that. You cannot cancel this x with that x because there's addition here. You cannot cancel this y with that y because there is addition there. In order to cancel numerator and denominator, everything has to be products in the numerator and products in the denominator. That's a big learning, especially when this gets abstract with those cosine, sine functions in there, secant, cosecant. All right, so on this next one, we are going to get the numerator to be one fraction. The denominator already is one fraction. And then when you divide fractions, you multiply by the reciprocal. So for in the numerator, the numerator's LCD is CS. And so this top one needs to be multiplied by S over S. And the second one needs to be multiplied by C over C. And we don't need to do anything with the denominator. It's already a single fraction. And so the denominator will just stay 1 over s squared. And in the numerator, we get an s squared plus a c squared with this new common denominator of sc. And then I can take the fraction in the numerator times the reciprocal of the denominator. In the numerator of the first fraction, you want to think of that as a quantity because of the addition. But then it actually is okay across multiplication to take this s and we have one of those gone. And we end up with s times the quantity all over c. Oops. You cannot cancel this c with one of these. In order to cancel, you have to cancel this whole thing, and you would have to have a matching s squared plus c squared in the bottom to be able to cancel the whole thing. So you can't do any more simplifying with that. Could I distribute the s? You can, but it's not going to lead to simplifying further, so it's okay in this form. It's okay if you distribute it, but it's not necessary. All right, so number 3. This goes back to a little bit from day 1. You do see a cosine squared here. And cosine squared is 1 minus sine squared, but there's no sine involved in any of the other parts of this problem. And so what they want you to recognize is that this is a difference of squares. Cosine squared minus 4. If you had y squared minus 4, you would get y plus 2, y minus 2. It's just a little more abstract because the denominator has cosine squared. And so when I see that that can be factored and that one of the factors matches the numerator, that is going to be a better choice. So getting to recognize that difference of squares, we've seen it a couple times in notes. Now, while there is subtraction in the numerator, the entire numerator matches this factor in the denominator. And in the denominator, these two factors are being multiplied, so it is okay to take this as a factor and this as a factor and cancel it. What I do not want to see is that you cancel cosine and cosine in the 2 and the 2 because that doesn't show a good understanding of the math. They're not canceling that way. They are canceling this factor matches this factor. So this factor matches this. Again, as you cancel, I want to be able to see underneath what it was before you canceled. Another problem with this one is when people see everything canceling, they make the error of just writing cosine x plus 2, but cosine x plus 2 did not move from the denominator to the numerator. It stays in the denominator, and that is your simplified. Okay, so we are just going to see some more examples of simplifying and of factoring on the back. Factoring where substitution is required. One of your homework last night had that in there. And then give you a worksheet to practice some more of these. Again, copy the original, work down the page, start a new sign with an equal sign. Well, in part A, there's nothing squared. There's not a secant squared or cosine squared, so I'm not immediately going to go to the Pythagorean identities. But I am going to go to the reciprocal identities, and secant is 1 over cosine. And the second cosine can be thought of as over 1. And those cosines cancel, and you end up with 1.
Could you just say that looking at the page?
Oh, I want, the question was, can you just know that by looking at the page? You have to, when you're simplifying and verifying, or simplifying, you have to show me all the baby steps so that I know that you really saw it. Good question. Good question. All right, and so in part B, for cotangent and sine, there's nothing being squared, so I'm not going to go to Pythagorean identities. And I do have a substitution for cotangent. Cotangent is cosine over sine. And so again, yes, you need to show that step, even if you can see it, just so that I know that you saw it. And so then the signs cancel and you end up with cosine theta. Make sure that as you go down that you have the angle arguments in every trig function. Sometimes people skip that. On the next one, again, things are not squared, so I'm not going to Pythagorean identities right away. And we have a mix of all kinds of trig functions. And there's nothing in common with the two terms, so I can't pull out a common factor. So one of the things we do is we just change things to sine and cosine. And secant is 1 over cosine. And then the sine can be thought of as over 1. And tangent is sine over cosine. So this is good because I'm getting two fractions that have the same denominator. And in the second, sine times sine is sine squared theta. So while we maybe thought that the sine and the tangent would simplify to just a single trig, it didn't. It became sine squared over cosine, but the good thing is they have a common denominator. And we have a 1 minus sine squared in the numerator. And this is one you're going to see frequently. Remember your Pythagorean identity, sine squared plus cosine squared equals 1. Solve that for cosine squared, and I get the 1 minus sine squared theta. And so this 1 minus sine squared theta is going to become cosine squared. And again, you have to show the baby steps. And then the cosine here cancels out one of those, and we are back at cosine. Are you doing okay? Keeping up? Am I going too fast? It's okay? All right. On the next one, I would change everything. It's going to be in terms of cosine because the reciprocal of secant is cosine. And so if I replace the secants with 1 over cosine, everything's going to be in the same trig function. And then just work it from there. And so here I have cosine theta times secant is 1 over cosine theta. Then minus, I can think of this as cosine theta over 1 times 1 over secant. It's the same thing. I'm just breaking it up into cosine over 1 times then 1 over secant. Because when you have secant in the denominator, what happens is it just becomes a cosine in the numerator. 1 over secant becomes cosine in the numerator. And here the cosines cancel. It's not 0, it's 1. So in this case, that next step you could write as the cosine times 1 over cosine, and then cosine times cosine, knowing that the secant, the reciprocal, becomes cosine in the numerator. I would be okay if you showed that step instead of this step. Either way that it works so that you get down to cosine squared. And that's what we just used, the other alternate formation of sine squared plus cosine squared. Here, if I solve for sine squared theta, I get 1 minus cosine squared theta. And so 1 minus cosine squared is going to be sine squared. You use those frequently. And that's as good as it's going to get. Moving on to the back side. Well, in part E, secant squared theta minus 1 is a difference of squares. And that is sometimes the route you want to go. It's not going to help me in this case because neither of those are going to cancel with secant squared in the denominator. But when I see the secant squared and a 1, I have a trig function squared and a 1, I'm thinking about Pythagorean identities, and 1 plus tangent squared is secant squared. And so if I rearrange that, secant squared theta minus 1 is tangent squared. And that will get me a single trig function in the numerator, and that's going to be a better choice than factoring. And so that secant squared theta minus 1 is tangent squared, and all over secant squared. And since 1 over secant is cosine, 1 over secant squared theta is going to be cosine squared theta. So on that next step, the 1 over secant squared can become cosine squared in the numerator because the reciprocal is cosine. If it helps, you can think of this as tangent squared theta over 1 times 1 over secant squared, as we did in the previous example. And then tangent squared is sine squared over cosine squared. And this is over 1. And the cosine squareds cancel, and you're left with sine squared theta. Which might bring up the question, when would we choose to factor? I believe something very close, if not the same, as this was in your... Oh, here, I do need to mention this. And you might have done this on your homework. I'm going to do it with a minus sign. I've seen people think that this is by the way that I'm going to talk about it, it's wrong. I see people think that these are canceling and these are going to just become 1, and they write the answer as secant theta minus 1. And that is not possible. You can't break that. You can't break it up that way. That's an illegal move for fractions. So how are you supposed to do it? You need to see that the numerator, in this case, you want to factor. And think of the denominator as a single factor, and then these cancel. It is factoring using a difference of squares. So if on that type of problem you didn't show the factoring as a sum and difference, you're not going to get credit for that. All right, and then this last one, factoring. This introduces when the trig functions are not all the same. And what you need to do is get them into the same trig function, usually. And in this case, again, I said knowing the identities can really help you problem solve. Because when I see cotangent squared, I know that 1 plus the cotangent squared theta is cosecant squared theta. And by knowing that, I go, oh, I can get these into the same trig function easily. And we've put these in the notes, and it's in the homework and on tests, and people will just leave it blank. What is, so you want to know that I need to change them to the same trig function in this case. And cotangent squared is cosecant squared theta minus 1. So replace that, and then we still have a minus 2 cosecant theta and minus 7. So it becomes cosecant squared theta minus 2, and then minus 8. And for the cosecant squared theta, you're going to need to start with a cosecant theta and a cosecant theta. If it helps you, think of it as x squared minus 2x minus 8, and how would you factor that? Things that multiply to be 8, but add up to negative 2. And you would get an x minus 4 and an x plus 2, and that would multiply to be that. But it's not x squared, it's cosecant theta. And so it just becomes cosecant theta minus 4 and cosecant theta plus 2. And your homework is a worksheet.